Hello everyone and welcome back to AI Competitions. In this video, we are going to solve another ongoing competition Analytics Olympiad 2023. If you go to problem overview, this competition was hosted by Sivanadar University in collaboration with MachineHack. This is the third edition of Analytics Olympiad. I was one of the finalists in Olympiad 2022. If you see, I presented my solution in Olympiad 2022. Back to Olympiad 2023. Analytics Olympiad 3.0 is based on the theme of predicting customers' loan default. If you see the problem statement, the main aim of this competition is to predict the customer loan defaults using credit history, payment behavior, and account details to build the model. This competition was held in 3 phases. Phase 1, solving the problem statement on MachineHack. Phase 2, they will ask for solution from the top 50 leaderboard contestants, and they will select the top 10 shortlisted contestants based on their solutions. In phase 3, there will be panel round. There you need to present your solution based on the presentation solution. The panelists select the top winners. Coming to the evaluation metric for this competition is they are using RAC AUC score. If you go to the prize session, you can see first winner will get the 1 lakh, first runner-up will get 30k, and second runner-up will get 20k. Coming to the data session, they provided customer level information, credit record information, loan overdue information, credit utilization limit information, some encoded futures and close flag, primary close flag, and final close flag. So in this problem, they provided 2 targets. One is the primary close flag and second is the final close flag. So we need to predict those 2 targets. We'll see more details while we are exploring the data. You can download the data from here. Coming to the leaderboard, you can see I recently submitted one base solution, so I got the AUC score as a 1. I guess there is some data leakage in provided data. I will try to give the baseline solutions. I will give you some tips to get this score, so I will easily get this score. To solve this problem, I'm using Kaggle. Just search for the Olympiad 2023 Kaggle. So we'll get the first link as the Analytics Olympiad 2023. So if you open that link, you will get the dataset. Someone already uploaded this dataset to the Kaggle. Here you can see they provided sample submission. So we need to predict the 2 targets, primary close flag and final close flag. They also provided training data. In training data, they provided 60 features, and in test data also they provided 60 features. To create new notebook on this dataset, just click on the new notebook. The Kaggle will assign you the new notebook. I already built the base model for it, so I will walk through the code directly. So first we need to install required packages. Solving this problem, I'm using the opt binning. Next, I imported all the required Python packages to solve this problem. Once the package is imported, I loaded the train data and test data and sample submission data. Here you can see the datasets. You can copy the path and paste it here. It will load to the pandas data frame. Now we'll see the dimensions of train data. They shared around 1 billion data points. For test data, they shared around 500,000 data points. Next, we'll look into the data frame.head. Here you can see all the columns they provided. Primary close flag and final close flag are our targets. Same for the test data, same columns they shared for the test data except the target 2 columns. If this is sample submission format, we need to predict the primary close flag and final close flag to submit the competition. Next, we'll go to the data processing step. First, we'll see is there any null values in training data. You can see encoded features having the null values. Test also, you can see encoded values having the null values. Here, applied customer ID value counts. Here you can see customer IDs are having multiple entries. Same I tested for the test data. In test data also, we have multiple entries for the customer ID. Here you can observe I plotted the Venn diagram for train and test data customer IDs. Most of them are the intersection. Here I filter for one customer ID. You can see for each customer ID, we have record number. So each record number, we have the target, whether the target is primary close flag or final close flag. Next, I separated columns into groups. Here you can see I created credit record columns. So all the credit related columns I assigned to credit record columns. Loan overdue related features I assign to the loan overdue columns, and all credit and utilization limit columns, credit utilization limit columns, credit utilization limit columns, all encoded features into the encoded features column. So we have two target columns here, so I assign to the target columns. Now it's easy to understand and analyze the different types of features. Now we'll see the describe of credit record columns. Here you have the record number, and maximum on credit records you have 47, and median you can see 50 percentile, you can see the 9 records. For days since open, median is 10 days and maximum is 19 days. Days since confirmed, median is 9 days and maximum is 17 days. You can see for all the credit record columns. Next, we'll see the loan overdue columns. Here is the loan overdue columns described. In loan overdue columns, here you can see some features having yes or no categorical string values here. So we need to convert into the binary values. For that, I selected all those features and converted into replace S into 1 and no into 0. So here you can see I did for train and test. For credit features also, some features having yes or no columns. For those columns also, I replaced the yes value into 1 and no value into 0. Here you can see the describe for the credit utilization limit columns. For encoder features, you can see the describe for the all the features they provided. Next, we'll see the EDA part. So here you can see the target distribution for the primary close flag and final close flag. Primary close flag, you have zeros for the 87% and ones for the around 13%. So there are so much imbalance in primary close flag, and also you can see the final close flag also, you see the more imbalance. So 80% are having the 0 values and 19% having the 1 values. Here you can see the value counts are normalized based on the target values. Primary close flag 0 and final close flag 0 are having around 75%, and you can see 0 and 1 having 11% and 1 having 7% and 1 0 having the 5%. So yes, you can see the most of them are having 0 flag around 75%. Next, if you see the correlation between the primary close flag and final close flag, correlation between those two are around 0.38, positive correlation. This is the final data we have after pre-processing all the columns. If you observe the customer length in training data, most of the customer IDs having 7 to 14 length. In test data, you can see the 2 to 7. Now we are going to plot distribution for the each feature using the plot feature distribution function. Here you can see I'm passing the train DF and passing the credit record columns. So here you can see the record numbers distribution. While record numbers increasing, the distribution also decreasing. Days since open distribution, event distribution, and days since confirmed 9 having the higher distribution compared to others. For remaining features also, you can observe the similar distributions. Here I plotted for the loan overdue columns distributions. Here I plotted the credit utilization limit columns. Here I plotted the encoded features distributions. You can go through each feature and understand each feature distribution. To solve this problem, I'm using binning technique. I divide each feature into bins, and then I will compute the weight of evidence and IB values. So based on the IB values, I will select the top features, and based on the weight of evidence, I will build the model. weight of evidence is nothing but distribution of good users in that bucket divided by distribution of bad users in that bucket. After that, we'll apply the logarithm. Here you can see the steps of calculating weight of evidence for a continuous variable. Split data into 10 parts. Based on the distribution, we are going to divide each feature into splits. Then calculating the number of event and non-event in each group. Okay, then calculating the percentage of event and percentage of non-event in each group. Then calculate the WOE by taking the natural logarithm divided of the percentage of non-event and percentage of event. Then we'll compute the information value IV. Information value is the one of the most useful technique to select important variables in predictive model. It helps to rank variables on the basis of their importance. If your IV value is less than 0.02, then the predictor is not useful for modeling. If your IV value is in between 0.02 to 0.1, then it's having the weak relationship with your target. If your IV value is 0.1 to 0.3, it's having the medium strength relationship. If your IV value is in between 0.3 to 0.5, it's having the strong relationship with your target. And if you are having IV value more than 0.5, it's having high relation with your target. If you want to read more on the weight of evidence and IV values, you can check this website. For selecting features, we are calculating IV values for each feature. We'll compute IV values and weight of evidence using the binning package. It's having inbuilt functionalities. We'll use those functions to build our model and select top features. Here you can see I mentioned the train, target and categorical columns and drop columns. Here we have two targets, so we have to build two models. Here I assign target columns to the target call 1 and target call 2. Here drop column list, I'm dropping customer ID and first name, last name and target 1, target column 2 from the training data. Here is the final train columns. Here you can see for target 1, for all the train columns, I'm getting the IV values from this function. So here is the top 10 IV values for the target 1 feature. Days till primary close feature having the higher IV value around 10. So this feature having very strong predictive power for the target 1. Same IV values computed based on the target 2 column. Here for target 2 column, days till final having the strong predictive power. Next, encoded loans credit status having the high predictive power. Here you can observe the top 10 IV features for the target column 2. Here I will try to explain weight of evidence for one value. Here you can see days till primary close, one of the important features for target column 1, right? So I will try to explain weight of evidence for this feature. If you see the distribution of this feature, the values in between 0 to 16. Based on that feature and target values, it's written the binning table. Here you can see the bins. I divided 0 to 16 into 4 bins, minus infinity to 1.5 as the one bin, 1.5 to 0.5 as another bin, 0.5 to 1150 as the other bin, and 11 to infinity as a one bin. Okay, for each bin, here counts tell the how many samples present. Count percentage will tell the percentage of that count values. Here you can see the counts for each bin. Here the count percentage of counts. Here the non-events and events. Here the events are the target equal to 1. Okay, here the non-events are the target equal to 0. Here you can observe while increasing the bins, your event rate is decreasing. So your bad rate is decreasing. Okay, from this you can observe that values increasing, the event rate is decreasing. Weight of evidence value is increasing. Based on the bins variance, you can see the IV values. Here you can observe that most of the event rate is present in only the bin 0. You can observe similar behavior for the target 2 feature. Here I plotted top 5 features bins and their plots. To train our model, I selected IV values greater than 0.02 value. So here you can see the 37 features for the target 1. Here I plotted correlation plot for top 20 features. You can see the correlation between those features. Coming to the modeling part, here I divided train data into train and validation data. Here I used a stratified split. For test data size, I am using 20%. Train data 1 and validation data 1 is for the target 1. Train data 2 and validation 2 for the target data 2. Here you can see again divided into X train 1, Y train 1, X valid 1, Y valid 1, and X train 2, Y valid 2, X valid 2, Y valid 2. Test data X test 1 and X test 2. Here I initialize the binning process 1 using opt binning process function. I assign the train columns 1 and cat columns. Same for the target column 2, I assign the binning process 2, train columns 2. Here I initialize the estimator 1 and estimator 2. Here I am using the simple linear model logistic regression from the scikit-learn. Here I mention scorecard 1 and scorecard 2, and using opt binning scorecard method, I pass the binning process and estimator here. What is model we are using? Here we are using the linear model. It will return the scorecard like credit scores. So scaling method, I use the min-max, and scaling method parameter, I pass the minimum value as a 300 and maximum value is 850. Same for the target column 2, mention the scorecard 2 here. Here I fitted the model 1 and model 2. Here I got the scorecard DF1 and scorecard DF2 from the model 1 and model 2. So here is the scorecard. You can see the model 1 scorecard, and for each feature, for each bin, you can see the points here. So we will see for one feature record number feature divided into 7 bins. For each bin, we get the score. Okay, here you can see bins are increasing. That means your record number increasing, your score also increasing. Here you will get predict probabilities also, because we pass the linear regression model from the scikit-learn. So using the predict probabilities function, you can get the predict probabilities. Here I calculated the ROC AUC score for both models. Here you can see model 1 train AUC score is 0.99. Validation AUC score is 0.99. So both are too close. For model 2, training AUC score is 0.98 and validation score is 0.81. Here I'm plotting the AUC ROC curve. You can see it's nearly perfect model. This is AUC ROC curve for the model 2. This is also too close. Based on the optimal thresholds from probabilities 2, I converted to 0.1 based on the optimal threshold values. Here you can see the confusion matrix for target 1. Here you can see the confusion matrix for target 2. Here you can see the classification report for target 1. Here you can see classification report for the target 2. I assigned the scores for model 1 and model 2. Then I plotted the scores for model 1 and model 2. Here you can observe the non-default and default. Default are the red ones. Red ones are having the less scores. And you can see the blue ones are the good non-default users. Here you can see the default user score and non-default user score. Similar plot for the target 2. Here also you can see the model able to distinguish between the good users and bad users. And more of the good users and bad users distribution overlap in between 400 to 500 score. Now we'll do the inference on test data. Here I'm using model 1 and model 2 predict probabilities function. I assign the prediction values to the test data, target 1 and target 2. Here you can see the predicted probabilities for test data. target 1 and target 2. Then I took the target 1 and target 2 and assigned to the sample submission. Then I saved sample submission as the base model solution.csv. Here you can see the final submission file. Once you got your submission file, you can go to this, and here you will find your submission file. Click on here. You can download here and upload to the competition. Once you upload your solution to the competition, you will get around 0.986 score. Here I used logistic regression model to train the base model. To improve your model, you can use tree-based models like GBM, XGBoost, and CatBoost to train your models, and use a stratified k-fold strategy to validate your CV. You will surely get top rank in public leaderboard. If you have any other doubts, contact me at LinkedIn. This is my LinkedIn profile. That's it from today's video. Please do like this video and subscribe to my channel. Thank you.